Hello everyone, welcome. In this video, I would like to demonstrate how you differentiate the natural log function, the exponential function, and the ordinary log function. Now, the way we differentiate the exponential and the ordinary log function is by converting them to the natural log function, because the formula we have for differentiation of logarithmic and exponential functions involves the natural log function. So here is the formula. So it says if y is equal to the natural log of the absolute value of f of x, then dy dx is equal to the reciprocal of the function f of x multiplied by the derivative of the function. And of course, the function should not be equal to 0 because division by 0 is undefined. Right, so let's look at the first question then. So here is the first question. We have y is equal to natural log of 3x squared. And of course, we don't have absolute value signs here because this expression here is always greater than 0 or equal to 0. Now, in this case, x is assumed to be greater than 0 or less than 0, but not equal to 0. Right, so number one, we have, these are our answers. Number one, we have y is equal to natural log of 3x squared. And following this formula here, we have to reciprocate the function and then multiply by the derivative of the function. So we're going to say, therefore, dy dx is equal to the reciprocal of the function multiplied by the derivative with respect, obviously, to x of 3x squared. Now, let's simplify that. This is 1 over 3x squared multiplied by derivative of this will be 3 times 2x. And the 3's cancel, and x, 1x cancels 1x down there. So my final solution then is, in the numerator I have 2, and in the denominator I have x. That's the final solution to question 1. And obviously x should not be equal to 0. X should not be equal to 0. Right. Question number 2, we have y equals 3 power x. And like I told you, in this formula here, we have to convert the exponential function to the natural log function. And I'm going to demonstrate how you do that. Right, so here is question number 2, y equals 3 power x. So I'm going to have to introduce natural log to both sides. So number 2, we have y is equal to 3 to the power x, and then we're going to say, therefore, natural log of y is equal to natural log of 3 power x. Applying the laws of logs, I'm just going to insert in here. We have the rule that says log base x of m to the power p is actually equal to p times log base x of m. This law applies to natural logs as well. So we can also say ln of m power p is equal to p ln of m. And so we're going to apply this rule here in order for us to be able to handle that. So let me move this one down here, and I'm going to say, therefore, ln y is equal to the power must multiply x ln 3. And remember, I have to differentiate on the left and on the right. Now, differentiating this, remember the rule says 1 over y times dy dx, and this will be equal to ln 3, remember, is a constant and derivative of x is 1. So if you like, we can say derivative with respect to x of x ln 3. Now on the left, I remain with 1 over y. On the left, I remain with 1 over y, and I have times dy dx, and this is going to be equal to derivative of x ln 3 is just ln 3 because derivative of x is 1. And so I have to get rid of this y. So I'm going to say dy dx will be equal to y ln 3. And what is y? Let's move back here. Y is 3 power x. So this is going to be, therefore, dy dx is actually equal to 3 the power x times ln 3. So this is the solution to number 2. Right, let's move on to number 3, the last one. Number 3, move this page. Number 3, we have y is equal to log base 2 of x power 3. There is number 3. So what do we do in this case? We must express this into or convert this into an exponential form. So converting this into an exponential form, the 2 takes the place of y, and the y becomes the power, and the log is gone, and you have equals x cubed. That's a short form or short technique that I use. So this implies 2 to the power y is actually equal to x cubed. At this stage, I have to introduce natural log on both sides. So I'm going to say, therefore, the natural log of 2 power y is equal to the natural log of x power 3. Applying this rule here, natural log of m power p equals p times natural log of m. You'll agree with me that this should be converted to y times natural log of 2 is equal to this one here. Because it's an expression which we have to differentiate, let's leave it the way it is. Now, on the left, I have to differentiate. And remember, ln2, natural log of 2 is a constant. So I'm going to say natural log of 2 times dy dx will be equal to derivative of this. Remember, the rule says reciprocate the function, then multiply by the derivative of the function. So this is 3x squared. Now, simplifying the right-hand side, what do we have? Remember, the x's cancel, and you have 1x in the denominator. So this is 3 over x. On the left, you have ln2 dy dx. Now, making dy dx subject of formula, it implies that we have to multiply by ln. We have to divide both sides by the natural log of 2. So this changes then. Our final answer to question number 3 will be, I'm going to say, therefore, if you understand here, dy dx will be equal to 3 over x divided by natural log of 2. What does this imply? It implies dy dx is actually equal to, if you like, 3 all over x times natural log of 2. So this is the final solution to the last question. All right, I'm going to stop here. If you're new to the channel, please support us by subscribing and inviting friends to subscribe. Let's share these videos with friends. I'm gonna have to come back with another video on, again, differentiation of exponential and logarithmic functions, but this time I'm going to include how to determine the equation of a tangent and a normal to an exponential function. All right, God bless. See you next time.